Day 1 of Phase 2 on the Stanislaus River. The Phase 1 AquaDam has been removed. All AquaDams have been removed. The new concrete spillway intake is in place. And we will be installing AquaDams against the face of that overflow weir, coming back upstream and reaching the bank somewhere over there. This will isolate the original existing concrete dam intake structure so they can remove it without causing turbidity or discharges into the water. The huge pit has been filled in, the concrete work has been accomplished, and so now we've got an area up top for the excavators to sit and hopefully pull on the AquaDam. Here's the back side of the existing concrete intake structure. This is the installation area. Approximately 6 to 8 inches of water flow is traveling over the top of this weir. The plan here is to start the 16-footer off the weir over there. The concrete structure is to my left. The work area is here directly in front, and the 16-foot tall AquaDam will be installed to the right. What may end up happening during installation is that smaller AquaDams are installed into the work area just to fill up the work area so that the 16-footer can be installed without fear of influence by outside water sources. The AquaDam can't move into the work area if the work area is already taken up with another AquaDam. AquaDam Inc.'s 4 3-inch gas-powered, 3-inch discharge gas-powered water pumps are being set up with suction hoses and a secondary containment area. These pumps will be used to fill up the 8-foot tall AquaDams as well as the final 16-foot tall AquaDam. Discharge hoses running up to the pumps and secondary containment, or those are suction hoses, and then there are blue discharge hoses running into the AquaDam, which has been rolled down the hill, a little 8-footer, just to fill up the work area. The pumps are pumping into the AquaDam. 3 pumps into the outside of the AquaDam, 1 pump onto the inside tube, that means left and right. 1 pump on the left side tube, 3 pumps on the right side tube, and that will cause the AquaDam to fill unevenly, making it turn. And on shore, there are men holding back the rope, which is influencing the AquaDam in the direction that we want to go. The 8-foot AquaDam is being tightly controlled with a series of ropes. We are pumping only into the outside tube, the right-hand tube, in order to facilitate this turn. Once we make the turn, we will fill both sides of the AquaDam evenly. It is currently being pulled over by ropes attached to the bottom seam under the pipes to where this worker is. These ropes will be tied off to these large sandbags, meter bags, and hold the bottom seam in place until the AquaDam unrolls over it. The 8-foot tall AquaDam has, we've stopped pumping on it. We're holding back the roll, and we're attaching another tie-off rope to the bottom seam to the existing concrete intake structure. The 8-foot tall AquaDam has been fully inflated and fully unrolled. It is installed into much deeper water than it normally would be, so not much is showing above water level. The reason that it's okay to install this AquaDam into water so much deeper than what it's rated to control is because we're not dewatering one side. As long as the AquaDam is 1 inch higher than the surrounding water, it will not be influenced by external currents. If we tried to dewater one side of the dam, the work area, then it would start to list and take the pressure of the external water pressure. But with equal water on both sides, it's just fine. A view from the closed end of the AquaDam. This AquaDam is very inflated, almost overinflated. The portion I'm standing on feels pressurized, and the baffle seam has pulled down in the middle, which means the dam is at least 8 feet tall at the baffle seam. It might be as much as 9 feet tall here at the closed end, at the tubing, on both sides. There's some kind of damage to the AquaDam here. I'm not sure what caused it. I think this was a used bag, so it could have been a result of previous use. Anyway, just a very small amount of water sheeting out of that hole into and collecting in the low spot between the two tubes and flowing out to where it can overflow up here. So there's so much water inside this AquaDam that losing this small amount of water is really not that bad. But so it should be accounted for though, and a string line put across the top and maintenance pumping performed if necessary. Well, it will be necessary because of the leak out of the top. Two excavators are moving the 16-foot tall, 255-foot long special closed-ended AquaDam. The starting end has the fill tubes coming up through the top, and the ending end has open-ended fill tubes, just like the start of a normal dam. So we will start with a double closed-ended end up on the wooden weir, and just begin filling the AquaDam, unrolling it upstream around the work area. The outer wrap is being cut off. The outer binding ropes are being cut off. And the unwrapped AquaDam will be set into the water, or we might drag the first 20 feet, or unroll it, and then set the partially unrolled assembly into the water to float into position. The 16-foot tall AquaDam has been unrolled down the bank a little ways, exposing the fill tubes. And now we're waiting for the jet ski to get into position. And I believe the plan is to tow the AquaDam unrolled side first towards that weir. Then lodge the fill tubes, or that end of the AquaDam, on the weir and begin pumping. The bag has been pulled up over the weir again, and now we are clearing the buoys over the top. Most likely we will pull this back to shore and attempt an installation tomorrow from the shore towards the weir. Second day of the Phase 2 AquaDam installation. We have retrieved the 16-foot tall AquaDam from on top of the weir and brought it along shore. And now we are pulling the fill tubes up and over. We will be installing an 8-foot tall AquaDam today alongside the 8-foot tall AquaDam that's already been installed. And tomorrow we'll be installing the 16-footer. Right now we need to offload the 8-foot tall AquaDams. The 8-foot tall AquaDam has been rolled down the slope. The fill tubes have been exposed up the slope, rolled down into the water. The 8-foot AquaDam has been unrolled down the slope a little bit, and now it's going to be pulled into place, position over there, I think. This AquaDam, 8 foot tall, approximately 150 feet long, is buoyant in the water because there's no water inside it, and the material it is constructed of is slightly lighter than water, so it floats. The double closed-ended 8-foot tall AquaDam is floating just off of the already installed 8-foot AquaDam. We're connecting hoses, and then we'll begin pumping it. We've tied off the closed end over here to the bank, as well as up to the shackle on the strap holding the log upstream. That will hold the AquaDam in place as we fill it up. The first 20 feet or so necessary to hold the AquaDam in place. And we will continue to fill, always keeping a head in the AquaDam and so that the AquaDam is independent of surrounding water conditions. The 8-foot tall AquaDam is now being pumped into, and its final positioning is being finessed currently. The upper end, the upstream side, has been tied back, so it can't go anywhere. This 8-foot tall AquaDam will act either as a spacer in the work area or as the final backup dam for the primary 16-footer. So this will be installed first to give us aid and support during the installation of the 16-footer tomorrow. Continuing to fill the 8-foot tall AquaDam. The AquaDam is very close to the end of its roll. It is a double closed end AquaDam. That means both ends of each fill tube come out through the top of the AquaDam. So there you can see the blue discharge hoses that have been already inserted into the fill tubes at the closed end. Very, very close to the end of the weir too, to the side of the weir. The closed end of the AquaDam has been tied back, or continues to be tied back. The pumps have been turned off, so no more water is going into the AquaDam. And now we're going to tie back that roll even more. It's only about 5 feet away from the edge of the weir. Pretty close. The reconditioned 8-foot tall AquaDam's fill tubes are being arranged so that they stay at a higher elevation than the rest of the bag. This keeps the water inside the AquaDam. Now that the second 8-foot tall AquaDam is installed, we are preparing the fill tubes of the 16-foot tall AquaDam. Multiple discharge hoses and suction hoses are being placed in the fill tubes. These will all be used to fill the 16-foot tall AquaDam, which will require approximately 400,000 gallons to be completely full. This will require a lot of pumping power for us to do this in one day. Luckily, the contractors provided some pumps to help out. Exposing the fill tubes of the 16-foot tall AquaDam. This is the open end of the 16-foot tall AquaDam. There are 2 fill tubes side by side. They have the white inner plastic, and our discharge hoses are being fed into these fill tubes. Getting water into the fill tubes is key for filling the AquaDam. Some residual flow that's coming between the AquaDams. The 16-foot tall AquaDam is being pumped into, which is causing the AquaDam to unroll. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 3-inch pumps pumping into the 16-foot tall AquaDam. It is unrolling very slowly. Very slowly. The 16-foot tall AquaDam is being tied off to the upstream log. This way we'll have a tie-off point, which is directly upstream of the AquaDam, making the turn making time much easier. "16-footer's filling up, and we're going that way. The blue and white buoys mark the outside edge of the AquaDam. The forklift driver is tied off to a large rope, which is tied off to the far side of the AquaDam, to the near side of the AquaDam log. Right there. And now we're pulling it out straight. The 16-foot tall AquaDam is tied off in several places, back to the log, as well as through a pulley, and back to the truck. Using a combination of ropes, force, and pulleys, we're going to position the AquaDam where we want it. Being held in place by two vehicles, the 16-foot tall AquaDam continues to fill. Currently, we are only pumping into the right-hand side tube of the AquaDam. The left and the right-hand side tubes are there. We're only pumping into the right side because that will be on the outside of the turn. We want to fill that tube up first. That will help facilitate a turn as well as making up the volume on the outside of the tube, outside of the AquaDam. The outer tube will require more volume than the inside tube. Inside of the turn, I mean. Upstream of the installation site, there's the upstream controlling log, and beyond it, the unrolling 16-foot tall AquaDam. An extend-all forklift is here on the bank, and we're using that to provide tension and pulling on the AquaDam as it goes. Water is flowing uphill, or kind of, between the AquaDams. There's the main body of water out there. Out there. Now the flow's coming around, and it goes here between the AquaDams. Around the end of the 8-footer. And then it comes back around between the two 8-footers. And exits right there. The 16-foot tall AquaDam continues to unroll. I guess first question should be, who are you?
My name's Will Scott, Civil on Reed.
Will Scott,
Project
Civil on
manager.
Reed, project manager. How long have you been working for Civil on Reed?
I've been since November.
What do you think about today's installation?
Oh, I think today's going well. We've got good control. The top, gone real smooth.
And is this the first time you've used AquaDams before?
It is the first time I have, yes.
Have you ever done cofferdams before?
I've done several cofferdams, not with rubber, mostly sheet pile.
Sheet pile dams?
Yeah.
And how does this compare to the AquaDam in terms of installation speed and cost and all that?
Mobilization for the AquaDam and the materials used is a lot easier. It takes less room on the job site. Seems to be a lot faster, and the teardown seems to be a lot faster.
Oh, that's right. You were on site for the removal of the Phase 1 AquaDams.
This is a great application for this.
The 16-foot AquaDam continues to fill and unroll. There's approximately 40 feet between it and the weir. We have tension on the lines, and ropes are beginning to break. But that's okay. We are replacing the ropes and tying them back to a ring rope surrounding the AquaDam, which goes, where is it? Over there. It goes around the circumference of the AquaDam. Once the AquaDam goes over it, it's basically a tie-off point now. So we are tying ropes back to it as well. The AquaDam is approaching the edge of the weir, approximately 20 feet. There's a rope. The other side of what? The rope, and it's moving. The last 6 feet of AquaDam are going to unroll here very shortly. We've already isolated one half of the weir. All the flow is going to the other half. This side is dry. The AquaDam has been restrained from unrolling, and a head has quickly built inside the AquaDam, approximately 14 to 18 inches above surrounding water level. The 16-foot tall AquaDam is very close to being fully unrolled, and I think it will not go past that side of the weir. The AquaDam continues to fill. AquaDam's completely unrolled, and the closed end is about 2/3 of the way across the top of the weir, which is perfect. The AquaDam is estimated to be 4 feet taller than the top of the weir when it is full. Currently, it's about 30 inches tall, taller than the. It's about 2 feet taller than the weir, but growing. The AquaDam installation is complete. The 16-foot tall AquaDam just needs to be brought up to its full height. The backup 8-foot tall AquaDam is in place behind the 16-footer. And the 8-foot spacer dam over here will be removed at a later date. Water is draining in the work area. There is a good 1.5 difference, or foot difference in water level between the work area and the watered side of things. This weir is dry on one side and flowing well on the other side. The AquaDam has diverted the flow to the right side of the weir. The 16-foot tall AquaDam is full. The work is complete. And we are done here. The AquaDam on the right will be taken out by the contractor. The AquaDam on the left will drain down until it is at 8 feet in elevation. It was much taller than that when it was installed into deep water. They round out in deep water. So we drained it down as the water level in the work area dropped down. We've already lost 1.5 feet of water depth in here. The 4-footer has terminated approximately 1 foot from the edge of the weir. Looks great. Solid, straight line. And not much else to say. We're done here.